Okay, so this warm-up is definitely a challenging one. The first one, I meant for it to be kind of straightforward, even though it is challenging. It still is a more straightforward question because it's not asking for anything crazy complicated like stationary points or points of inflection um, or like part B of question 2, where is it not differentiable? It's a question I've never asked you before. Okay, so let's go through part A or problem 1. I just want to show one question at a time. Okay, so the first thing that I see here is that the outer function is this power of 5, and the inner function is this rational, which is quotient rule, right? And the outer function is a power, so it's a composition of functions, so it is definitely the chain rule. So the chain rule is involved and the quotient rule is involved. That's the first kind of big picture thing that I look for when I'm trying to solve these. So what rules are going to be used? And then I try to decide in what order are they going to be used, right? The outer thing is kind of the thing you do first. So I would definitely use the chain rule first. And then while you're doing the chain rule, specifically when you're finding the derivative of the inside function, that's what's going on over here, then you're going to use the quotient rule. Okay, so if you can kind of think about a game plan before you start, it's going to really help you out. Okay, so you can see the power rule is being applied here where the 5 is coming out to the front. We're subtracting 1 away from the 4. This is like the derivative of the mama with the baby inside, right? And then the derivative of the baby on the outside. So basically, I just kept everything in here exactly the same, 2x minus 3 over 7x plus 1. And then we multiplied by the derivative of the inside, which is the derivative of the numerator first, which is how I got that 2, times the denominator 7x plus 1. And then subtract the derivative of the denominator, which is 7, times the numerator, which is 2x minus 3, over the denominator squared. Okay, now, in all of these problems, it's really important that you simplify. Did I say that in the problem? Yeah, evaluate and simplify. So in simplifying this thing, we can actually do some algebra on the numerator. Distribute in the 2, distribute in the 7 with the negative sign as well. Did I do that correctly? Yeah, negative times a negative becomes positive 23. We end up with a negative 14x and a positive 14x, so those cancel out. So I basically just have 2 plus 21, which is 23. And then we're multiplying these things. So basically, I can multiply the 23 times the 5, and that's how I got 115. The numerator, the 2x minus 3 is to the 4th power. But down here, this is to the, oh, I did that wrong. Down here, this is to the 4th power and the 2nd power, so that's going to be to the 6th power. Whoa. Make it look reasonably right. Okay. Okay, questions about number 1? Okay, so definitely going to involve the quotient rule for finding the derivative of this. But then within the quotient rule, look right there. It's x times e to the x. So that's the product rule within the quotient rule. Kind of crazy, right? Okay, so the quotient rule is the whole thing. But as soon as we start, we have to take the derivative of the numerator. That's all of this right here, okay? All the stuff in parentheses. This right here, I'll highlight in kind of a color. Finding the derivative of that part right there is just this right here. Okay, so using the product rule, we do the derivative of x, which is 1, times e to the x. So it's 1 times e to the x, plus x times the derivative of e to the x. Well, the derivative of e to the x is itself. So that's how I got x e to the x. Okay, and then we have to subtract the derivative of e to the x, which is itself, e to the x. So that just stays the same. So the hard part in the parentheses is using the product rule on the part that I've got highlighted there. Okay, before I go any further at all, questions about just that part? Okay, so that's just the derivative of the numerator in the parentheses. Okay, then I multiply by the denominator. This is like f prime times g, right? And then I subtract, because that's in the quotient rule, there's a minus sign. The numerator, as it is, that's exactly what the numerator is, no changes, times the derivative of the denominator, which is 2x, all divided by the denominator squared. So x squared squared is x to the 4th. Okay? So that's our first move, but we're going to want to simplify this because working with this ugly thing is just a mess of algebra. So what I did was I distributed this in and got all of those guys there and combined like terms and all that good stuff. Multiplied everything in here by negative 2x and then combined like terms to end up with this expression. So you might have wanted to do an extra step in there. I definitely did a whole lot of math to get to this point because I'm doing all the distributing and collecting like terms all in one step. Okay, so between here and here, you might want to show more. Can you see what I was thinking when I did that? Did you have any questions? Okay, as we go forward now, I can still combine like terms because, like, for example, this one right here, I got 2x e to the x and minus 1x e to the x, which just made this 1x e to the x. Those all combined into that. And that's what I did in the next step. So it's a further simplification, combining like terms. Okay, and then I factored out an x. So all of these terms up here in the numerator have an x in them. I factored it out and canceled out. So that's why the denominator turned into an x cubed when it was an x to the 4th before. Okay, so then we end up with the final thing in the light blue box at the bottom. Questions about that part? We still need to find the stationary point and all that. And you're asked to find the y value as well. Okay, this is something you guys need to be able to do without a calculator and the kind of thing you're going to have to upload a photo of your work for, right? Okay, moving forward. So now if we set this equal to 0, this is a fraction right here. And a fraction is equal to 0 if its numerator is 0. Think about that for a second. Let's say we plug a bunch of numbers in there and we get 0 over 10. Isn't that 0? We don't care what the denominator is. Okay, a 0 divided by a number is 0. So therefore, all I have to do is think about this numerator equal to 0, which is what I'm doing over here. And in fact, I can ignore the e to the x. We've actually talked about this. This has come up. If you think about what e to the x looks like in graphical form, it's something like this, and it'll never equal 0. So this right here, e to the x, will not equal 0. So all I really care about is this parenthesis equal to 0, right there. That makes sense? Okay, so if I set that equal to 0, then I can factor it, and I get x minus 1 times x minus 1, which means that x equals 1. And that's really amazing, actually, if you think about all the algebra going on in this problem, we end up with a really nice, clean answer. And if you plug 1 back into the original function, which is what's going on down here, then you end up with y is 0. Because you get 0 over 1, which is 0. So y is 0. So the point 1 comma 0 is the stationary point. So sometimes problems are going to ask you just for the x coordinate, and sometimes they'll ask you for the full coordinate, which you have to find the y value too. Okay, that's part A. Any questions there before we go on to part B? Here we go. All right. So for part B, it's actually a quicker problem than any of the others, because once we have the derivative, we're looking for when there is no derivative, and that's when there's like breaks or holes or asymptotes or things like that. And if you look at the denominator, we're not allowed to divide by 0. So it's undefined. The derivative f prime of x is undefined when x cubed equals 0. In other words, 0, right? Because 0 cubed is 0. So x cannot equal 0. If x is 0 in the original function, there is no derivative. Every other point is fair game. It's totally fine.